implement. We need a vertical line. Doesn't look semicircle. Okay, we have the next one. This is P naught to P naught, 4 P naught. This is V naught to V naught. Okay, 1 mole of monoatomic gas will undergo a cyclic process as shown. So there's a path 1, 2, 3. Some curved one, I brought it. Okay, no, so 1 mole volume, there's a pressure. 1 mole of undergo a cyclic process 1, 2, 3, 1 as shown. Find efficiency of gas in 1 full cycle. Yeah, the same thing, we have to calculate the efficiency. Okay, now carry on. How identify the paths? Let's see. There's a what is path 2, 3 part? There is path semicircle. I'll write it. Let me add that. Okay, there's information. It's not any other curve. It is just a semicircle. Okay, go for it. What is 1, 2? Isochoric heating. Straight away, we can say isochoric heating. Volume constant, pressure increases, so isochoric heating. It will be absorbed. What about 3, 1? Anybody wants to comment on 3, 1? Process 3, 1. Isothermal?
No, sir.
No, it cannot be isothermal. No, temperature, in fact, is varying. Adiabatic process? No, it should be like some sort of curve. Isobaric, pressure varies, volume varies. So it's a general thermodynamic process. Okay, so these are just some essential things. Huh? Okay, what about semicircle 2, 3? I'll give one number 4 also. Okay, 2, 4, 3. For our convenient purpose, I just wrote 2, 4, 3. 2, 4, 3 is a semicircle Again, it's a general thermodynamic process. And what about 3-1? Work done, volume decreases, work done negative, finish over. Temperature will decrease, no? So therefore, both are negative. So it will be rejected. No need to write down formula. Straight away you can predict. What about the path semicircle here? Work done, positive or negative? Work done, positive. Volume increases. Temperature increases or decreases? That we have to verify. Yes, temperature will increase. So it will be absorbed. Okay, no. So these are the some 2, 4, 3. I wrote it so that will be easy for us. Or if you want, I'll remove that 4. I'll remove that. Some of you are asking, sir, what is 4? I'll remove it. Okay, Q2, 3. Okay, let's get into thing. Now, I want efficiency and I'm having only 2 minutes time. What shall I do? Area under PV graph will give network done, no? Area under PV graph will give network done. So first we'll calculate network done. What all areas we have? Check it. Triangle. All of you, geometry, area of triangle. Semicircle, yes, we know how to calculate area of semicircle. Adding up these two is work done. But sir, cyclic process, clockwise cyclic process, work done positive. So area of the semicircle pi half into, let me start it, half into pi r square. One diameter is how much? One radius is 2p naught. So what about other one is v naught by 2. It is, so therefore this will be pi. Okay, this is okay, this much here, plus this is semicircle. Next for triangle. Okay, for triangle, off into off into I 2p naught minus p naught, base 2v naught minus v naught, pi p naught v naught by 2. This will be p naught v naught by 2. So p naught v naught by 2 you take outside, pi plus 1. Okay, don't get shocked when you see some sort of pi in options. I don't know, some students by looking at options only they'll say goodbye to question. Maybe some circle might be there, log. Okay, due to isothermal process log will come. I think in that way what our thinking should be there. Okay, after this what happened? Q positive is what I'll calculate. So Q positive, where all it is absorbed, Q1 2 and Q2 3. Sir, why 3-1 it is rejected? Yes, in fact temperature you can see here, ideal gas equation you applied. Temperature here how much it will be? T naught, no? Let me write those things. So temperature set. I think first we'll go for writing temperatures. It'll be easy for us. Okay, no. Temperature at 1. So we proceed like this. For somebody's convenient, I'm writing it. So therefore, what is T1? You can write P naught V naught by R, which is T naught. There is a method. Then temperature at 2. So what is the thing? 2 P naught, volume V naught equal to R T2. So what do we expect now? T2 should be 2 T naught. Okay, temperature at 3. 4 T naught, directly 2 P naught, 2 V naught by R. Please, in exams, you can't write so many equations directly like rough diagram, or you should write data T1, T naught, T2, T naught. This one. What do you mean by T naught, P naught, V naught by R? Because this will help us to write equations. Because most of the things we express in terms of temperature. Okay, now let me get into isochoric process. N CV T2 minus T1. And next Q23. We don't know. Anybody, any formula? We don't know formula. So it's a general thermodynamic process. So what is the formula? Delta U23 plus W23. Now number of mole 1, monoatomic gas, T2 to T naught minus T naught. One question, if a student is able to solve on his own, then if you plot a graph, he can do any problem. That confidence you should gain. Delta U23 N CV T3 minus T2. W23, do we know W23? We have to calculate that. How to get W23? It's a big headache. Semicircle plus rectangle. Okay, semicircle plus rectangle. So let me go for it. W23 semicircle, we know it. How much? Pi V pi P naught V naught by 2. Pi P naught V naught by 2. Plus next again the rectangle. 2 P naught V naught. Hope everyone is able to get. So what is this? What is pi P naught V naught by 2? Area under semicircle. Next area of this part, 2 P naught into V naught. Okay, this is, I think I can help you at least this much. That yellow color is because of that one. Let me go for the next part here. So this will be 3R T naught by 2. Number of moles 1. So this also 3R by 2. T3 is how much? 4 T naught. 4 T naught. T2 is how much? 2 T naught. Bracket. Okay, this should be the R T naught. We'll write it as P naught V naught. So 3 by 2. So this will be 2 T naught. So 3 P naught V naught. Pi P naught V naught by 2 plus 2 P naught V naught. Pi as it is I should take. So here 3 plus 2 5 Okay, sorry for disturbance. Okay, we'll continue now. Yeah. I think we were here, no? Anybody value pi plus pi by 2? P naught V naught pi by 2. Anybody value 5, 5, 1.5, 6.5, 13 by 2. Is that okay? Pi plus 13?
Yes, sir.
Huh? Okay, no. So we know Q positive. And we know network done. So we'll get the required answer efficiency. So now what happened finally? You are in a better position, no? What are the type of graphs you can do better? Okay, can you, these are the types of different shapes. So now you go for different varieties of graphs. Not only this, let it be of anything. So you must be in a better position to identify what is the process and what about the efficiency. See, one thing, sir, whatever the graph means, sir, means even